This is in 2004. You can see there at the yellow star that the glacier has lost a little bit of its height, and here it has disappeared. But then how it looks like in year 2100, like this. So no glacier at all. This is, of course, modified picture, but based on real calculations from a paper from Juve and US, published in 2019, where you can see that this glacier has almost disappeared. Its length has been reduced of about 80%, the area of 50%, and the volume of the 75% compared to year 2017 under the RCP 4.5 scenario. But why we are so interested in glaciers? Glaciers are, of course, a source of fresh water, so they are really important for us. But for me as a scientist, and for all the scientists that are studying these glaciers, glaciers are an important archive of information. In glaciers, actually, we can know the story of our past, of the past atmosphere of the Earth. I really like thinking as glaciers as a sort of historical textbook of our past. Layer after layer, page after page, we are able to discover and to unravel the secrets of the past atmosphere. Through their analysis, we can reconstruct the climate. So we can reconstruct the concentration of greenhouse gases that were in the atmosphere, such as methane or CO2. We can reconstruct the main biomass burning events that happen in our planet and see which is the link between biomass burning events and climate. So how biomass burning events influence climate, but also how climate influenced biomass burning events. We can also understand and reconstruct past volcanic eruptions and see how they influenced, which was their impact on the climate. But also, we can find the fingerprint of men, so the anthropogenic fingerprint of the environment through the fossil fuel combustion. And this is an example. So how we can read this book, which is not written in English, in Italian, or in French, but it's written into a chemical alphabet. And this is the letter. These are the letters of the book. This is how this book looks like. And you can see here the year, so from 1700 to 2000, and several lines with different colors. Just have a look at the blue line, so Europe. Sulfate is the proxy, so-called indicator, let's say, of anthropogenic combustion of fossil fuel. And you see that from the beginning of the 1750 to the beginning of the 1900, its concentration is more or less stable. Then something happened. Then we see an increase of sulfate. And this is a clue of our impact on the environment, the impact of the combustion of fossil fuels. But then I think that also this plot, this graph, contains a hope message, because look at the peak of this, so the highest value of sulfate in the atmosphere. That peaked in the 1970s, and then a decrease. And this is the effect of the implementation of really effective environmental policies. And this, I think, is a really important message for hope, because if we introduce some strict environmental policies, we are able to improve, and we did it, the air quality of our planet, where we live. Unfortunately, these books are endangered because of global warming. And this is a picture I took when I flew over Greenland. And you can see in white the Greenland ice sheet, so beautiful, so white. And here, water. Water due to summer melting. And this is, our nightmares in terms of ice core scientists, because water that forms on top of the glacier during summer, then it can percolate. And through the percolation, it's like throwing a glass of water on a page of a book. Then the information that was really clear, page after page, it becomes mixed. And then for us, it's really difficult to interpret what was the original information in the ice. And so it becomes even more difficult to reconstruct the past environmental condition of the Earth. This is the reason why in 2015, this initiative, the Ice Memory Initiative, was officially launched. Before it was an initiative that involved the CNRS and the CNR, so France and Italy. And then year after year, more countries have been involved in this project. And the aim of this project is actually to collect ice cores from the glaciers all over the world before it's too late to save the information that is contained and preserved into the ice. Then this core, let's say 2 cores, one is analyzed with the best techniques available today, is the reference core, to create a sort of archive, the best knowledge we can have of today of the condition of the Earth and of the atmosphere of the Earth. And then the second core is the so-called heritage core. So it will be shipped to Antarctica, and it will be preserved there for future generation scientists that will be able to do maybe some discoveries that today are simply impossible. And then last but not least, the aim of this initiative is also to educate and train young researchers through the activation of PhDs, postdocs, and also the involvement of master students. We have done a lot of work in terms of ice memory since everything started in 2016 at the Col du Dôme in France, where the first cores were collected. Then in 2017, we went to the Illimani in Bolivia. In 2018, Elbrus, Caucasus, and Beluga, Siberia. In 2020, the Grand Comben at the border between Switzerland and Italy. And again, in 2021, always at the border between Switzerland and Italy at the Colle Nifetti, where we collect 2 cores there. And the future, of course, I mean, there are still a lot of glaciers, even if they are disappearing all over the world. And so in the future, the aim of this project is to collect as many ice cores possible to preserve them then in Antarctica. And one of the future steps will be the Kilimanjaro Glacier, one of the last glaciers that is surviving and is suffering, of course, in Africa. These are some pictures from the last expedition at the Colle Nifetti, so also to have an idea of how an ice core drilling campaign is. So we have here the drilling tent, so where we collect the core. And then you can see on top here the Capanna Margherita hut, which is the highest hut in Europe. This is the inside of the drilling tent. This is the core barrel, so when the core is extracted and collected, meter after meter, down to 80 meters depth. And this is the core. And maybe you can see it here. It's a little bit yellowish. And this is a clue of a past Saharan dust event. So a Saharan dust transfer from the Sahara to Europe, which is quite recognizable also as a naked eye. And then, as I told you before, all these glaciers will be shipped, also, all these ice cores from these glaciers will be shipped to Antarctica to be stored there for the future generations. We already started to analyze these cores because they were like the reference cores, so to have the best knowledge possible of the conditions of the past atmosphere, but also of the glaciers themselves. And I think that this plot, then I'm going to explain it briefly in a while, is quite impressive. So here we have 2 cores collected from the same location. In 2018, the gray line, and in 2020, the orange line. So in principle, these 2 lines should overlap along the entire period. And it's something that we can see, so from 2020 to 2016. But then something happens. So the 2 lines have 2 different and completely different behaviors, completely different trends. And I think that we believe that this behavior is due to summer melting. And it's the first clue of the destruction of the chemical signal preserved in the ice cores themselves. And considering that this glacier, the Grand Comben Glacier, is located at 4,200 meters of elevation, this is the effect of melting. And so melting is happening also there at 4,200 meters of elevation, which is really worrying. And also this can give us an idea of how fast we need to proceed to save these cores. This is true also because we have new analytical techniques available on the market, and who knows how many new analytical techniques they will be available on the market in the future years. That these techniques can help scientists to make discoveries that nowadays are simply impossible to make. And so acting fast, it's really important for not only for us, but also for the future. Because we can discover something that now it's not possible to discover. And this is crucial also for the future understanding of how the Earth system is and will evolve. And that's it. And I would like to thank you for your attention. If you have any question, of course, of curiosity or anything.
Thank you very much, François, for this great presentation. What a fantastic project to be a part of. Thank you for sharing this today.